Welcome back to this track, AI and Democracy. We are now heading towards our keynote speech, which is going to be held by Professor Rayid Ghani. Rayid is a professor at Carnegie Mellon University, where he works at the intersection of machine learning and public policy. He is also behind the well-known Data Science for Social Good initiative. He has been participating in numerous non-profit projects, and he has also been the chief scientist for the Obama campaign in 2012. Rayid, it's a great pleasure to have you here. In the morning, we started our track with discussions about elections, campaigns. In the afternoon, we moved toward how nonprofits may use AI to pursue their goals. And then we moved to how governments may actually rely on machine learning to pursue better public policies. So in a sense, I'm glad that you're here because you're the personification of all the topics that we have been covering today. It's really a great pleasure to have you here. Thank you for your time. And Rayid, the floor is yours.
Thank you very much. Thank you. And I think, that progression makes a lot of sense to me is, because exactly as you mentioned is, when we talk about sort of democracy, elections and politics, it's important, of course, in thinking about how you get the right government in place, how you get people involved, but then governing also takes the effort, right? And if you look at it in terms of the use of AI, it's a little bit, it's similar and it's different. And it's similar because you're still trying to figure out, how do I design in a campaign? A lot of it is really about, how do I allocate resources in order to win? How do I persuade people to vote for me? How do I get people to actually vote? How do I people in the US, you have to register to vote. So, but the goal there is to just get enough votes to win, right? That's sort of, you can always get more, and more is better. But a lot of campaigns sort of focus on trying to get, how do I win? Whereas in governing, that's not the goal. The goal is not to just, help the 49.9 or 50.1% of the people who voted for you and forget the rest. And that makes the underlying technology is similar, but the overall policy goal is very different. The goal might be to make sure that everybody has access to things, services that they need. So I think for me, that link is really, that distinction is important. And that's kind of what I want to talk about today is really, in a lot of problem projects I've been working on over the last few years with governments and nonprofits in different policy areas, that distinction comes up very, very, very clearly. So welcome. Thank you for inviting me here. So what I want to start with is just kind of giving you a few examples of where we've been kind of using all the buzzwords that we're talking about in different policy areas, right? So I'll start with kind of an example from a while ago that we started, and that is around public health, and specifically lead poisoning. And it's a problem in a lot of different countries. In the US, it's been a problem mostly because of lead paint. Every home built in the US before 1977 had paint that has lead in there. And when paint gets old, it starts shipping, kids crawl, they pick up this dust, and then it goes into their bloodstream, and pretty bad things happen. The biggest sort of issue with that problem is that it's irreversible. All the effects are irreversible. Once you are exposed to lead and you have these things, there's nothing you can do to fix the problem. And so most governments here, the way they deal with it is they basically wait until somebody gets lead poisoning. So they test kids for lead. And if they find lead, then they go in and try to look for the sources, which is typically your home. And they tip 90% of the time they find a lead source, because how else did the kid get lead poisoning? And then they start fixing that problem. So basically what the essential policy is, we use children as sensors to detect lead. They're extremely accurate. It's horrible, but that's what we do. And then we use those sensors to fix things for the future children. And it's because of resource constraints. They can't fix every home. So they're using these sensors to fix homes to find homes that have problems. And so, it's a horrible policy. It's too late. It's not effective for the kids that are being, hurt. So we started this project started a few years back in Chicago, where they came to us and said, we know this is bad. We know we're not doing, not being proactive, but we don't have the resources to fix every home. We don't even have the resources to fix homes that have kids. So can you help us prioritize which homes to focus on? And again, the ideal solution would have been to get the resources to fix every home that has this problem. That was not the case today, and that was not the case yesterday, and maybe it will be tomorrow. So what we did was we worked with them to figure out how can we be proactive about detecting which homes have lead hazards. And we took data from them for all the blood tests that had been done the last 15 years for all the kids. We got data from them, all the inspections they had done, because those were kind of the outcomes that we were looking for. Is lead hazard in the house or not? And then we looked through all the public data about housing and what this house, when it was built, what the structure was, all that. And we used that to figure out, can we predict when a kid is a month old, 2 months old, 3 months old? Generally, kids crawl at about 9 to 12 months. So the idea was to be able to predict early enough that this child is going to get lead poisoning, so that the health department has time to go check their home, and if they find a problem, fix it. And they needed about 6 to 9 months to be able to go through that process. So we basically took every child between 0 and 3 months, and we use all that data, combine that to predict who's going to be at risk. And we use those predictions to then prioritize lead inspections in homes and then remediations. So that system is now being deployed, and it's been running in Chicago, and both in the health department, but also start extending it to then working with hospitals to get to pregnant women. When they come in for a checkup, the system can then flag and say that the child that's going to be born will be high risk. So can you focus on these homes? Now you have more time to plan and allocate resources so that the kid is never exposed when they're born to any lead hazards. So that's one example. I'll come back to a couple of these. Another depressing example is policing, which is lots of horrible things happening in the U.S. around the use of force and police misconduct. And again, if you actually talk to police departments, you'll find out that they actually have these systems they call early intervention systems in these departments. And what they're supposed to do is raise an alert when a police officer is likely to be involved in one of these horrible things that they shouldn't be doing. Except they sort of built these systems, and they were kind of these standard, they came up with a bunch of rules around if somebody has used force in the last 30 days, if somebody has had complaints in the last 90 days, all those types of things, raise an alert. They built them, they installed them, and then they were done. And they never bothered to actually evaluate any of these systems. So again, a few years ago, we started looking at working with them to see, do these systems work? And when we evaluated them, we found that they were completely useless. So one of the departments we were working with, and when we evaluated their system, it turns out that it was flagging about half the police officers in the department, which made it completely useless. Nobody trusted it. But even from a statistical side, it would flag half the officers and get slightly larger than half of 52% of the officers who were going to go on to do these things. So it was pretty much a random system that they were using. And so we kind of stepped back and said, okay, what can we do here, right? Can we take this, do we have even information or data to be able to raise these alerts? So we took everything from these police departments, their history, their training, their complaints, their arrests, their stops, their everything, and their investigations, and said, can we identify officers who are more likely to be involved in these incidents? And step two was, can we then try to figure out how to stop them, right? Because again, predicting is often easier, but if we just predicted and watch these police officers then shoot people, that would be horrible, it would be useless. So the idea was that, yes, we can predict which officers are likely to be involved, but then what are the interventions to try to prevent that from happening? And what we found was sort of a few types of indicators that made these officers high risk. One was obviously previous incidents. And in this case, something, it may be not that there is no way to actually fix it other than, you shouldn't have hired these people, you should have trained them differently, but you kind of have to put them, maybe give them a cool down period, give them training, give them something else. But then we found other factors like domestic, if they were repeatedly dispatched to domestic abuse cases, especially involving children, they became high risk of doing these types of things in the near future. Or if they were dispatched to suicide attempts, they became high risk again in the near future. And those were sort of indicators of stress that is possibly coming through the dispatches they were set on. And so one thing the department we're working with has been doing is they hired a counselor to sort of see, can we try to figure out how to reduce that level of stress? How do you not send them to those dispatches if they've been sent on one recently? So again, that system is now, it's been implemented for a few years now in a couple of departments. And one of the things we're working on right now is getting that data back to be able to evaluate the reduction in police misconduct as a result of these things. And again, I'm going to go through these quickly, but there are write-ups and papers for all of these that are available that I can put on my webpage and other places. So here's another kind of example, which is, again, criminal justice system is pretty horrible in the US. And these numbers that you're looking here so there are jails and then there are prisons, and jails are typically sort of at the small, short stays, city, county level, and then prisons are kind of state level and federal level. So these are just numbers for jails in the US. 11 million people in the US go through jails in some way or another in a given year. Yes, it's expensive, but the horrible part is that 2/3 of those people have some sort of mental illness, substance abuse disorders, chronic health issues. And so often these factors also result in them coming back repeatedly and over again. And so one of the organizations I've been working with in Kansas, what they came to us with said, look, we know we have a high rate of recidivism. People come back, but we think it's not because of something inherent, because it's because they have needs, they have mental health needs. And because we can't provide them mental health services, it results in them getting arrested, getting booked into jail. We have some resources to try and provide people with mental health resources, and we want to use those resources to reduce recidivism. So the question they came to us with was, is there a way to identify people who are high risk of recidivism and have mental health needs, such that if we provided them with mental health services, it would reduce their risk of coming back to jail? So for us, there were sort of basically three questions we had to answer, right? One is, can we identify people who have previously been in jail and are likely to go back in the near future if nothing was done? Two was, do they have mental health needs? And the third question was, if we connected the two, if we took our high risk people and intersect with the people who have mental health needs, how do we pick the ones that, if they were given these resources, it would reduce their risk of going back to jail? And so what that that required us to do was, one, connect data about these people across different systems, across the criminal justice system, across the health system, across other types of social service systems, and kind of connect these people to figure out, one, we use that to predict who's going to come back to jail. Now, that could be a horrible thing to do if you were giving that information to the police, like, hey, and we've seen all the horrible things that have happened with things like predictive policing, right? But the the act of analysis of predicting who's coming back to jail it's horrible if you're going to try to use it to preemptively do something and arrest somebody. But if you're using it to then direct resources that they need, mental health resources, that's a different goal. So what we did was first say, can we predict who's going to go back to jail? And we found after running the trial, we could do that very accurately. Second was we looked at their history to see whether they have a mental health history. So that kind of gives us this set of people who have some mental health needs. And step 3, which we started about a year and a half ago, was a randomized trial that we would give them a list of people who have, what they said was, we can help about a couple of hundred and something people every month in terms of resources as a trial. So we would give them a list of these people. They go out and connect with them through mental health outreach people. And then we've been getting that data back to see their future outcomes. And what we're sort of testing, which is still going on right now, is one, whether providing them with mental health services reduces their risk of recidivism. So does this actually work? Because the whole goal is to change this outcome, again, not to predict, which we know we can do really well. But then the second thing we're measuring is whether different types of people have a different reduction in recidivism. Because if we built a system that was on average correct, but it was really bad for some people and so very good for some people, we want to then design the program to figure out who's being left behind so that we could create new services and make sure that people are not being left behind. So that trial has been running for about a year and a half, and by this June, we should have data back so that we're able to evaluate and see both overall effectiveness, but also what types of people what types of people does it work for, and what types of people does it leave behind. So basically looking at these types of projects, right, there are kind of 3 pieces and here that we're looking at, right, we're trying to understand what types of people come back to jail, what types of people have recidivism, what types of police officers tend to, have misconduct, what types of children get lead poisoning. The second that we're looking at is then we're trying to figure out, can we predict who's going to do one of these things in the future? And the prediction is not just for the sake of prediction. The prediction is used to then prioritize who to focus on. But then again, both of those things are completely useless if we can't then change what's going on, because the goal is not just to understand and write a paper. The goal is to understand and then try to change their outcomes. So the third piece becomes, how do we influence their behavior? How do we change their behavior in order to actually change the outcomes that we care about? And if you notice that this structure is not just for these types of problems. One, it also occurs in politics, in elections. This is exactly what we're trying to do with voters, trying to understand what types of people vote for you, what types of people don't vote for you. You're trying to then predict who's persuadable, and you're trying to then influence them in order to change their voting behavior. Unfortunately, this is the same structure with marketing, selling you useless things that you don't want. You're trying to understand who's gonna buy it, who might be persuaded to buy it, and then trying to change your behavior. So any type of kind of human behavior change type problem, this is the structure that we use. Now, one of the things that's sort of different in kind of the types of problems I talked about, not that different, but there are kind of 3 characteristics there that we're looking at. Right? One characteristic is that none of those problems are kind of automated, autonomous systems, right? They're not. I'm not pressing a button automatic, or even just automatically removing lead poisoning. I'm not automatically providing mental health support. It's a mental health services person going in. It's a counselor talking to a police officer. So all of these are kind of these collaborative systems where AI machine learning is playing a role, but it's eventually a human that's taking an action. The second thing that's sort of common here is that in all of these cases, unfortunately, we have limited resources, which is sort of the systemic problem underneath. That's the problem we actually have to fix in the long term. But in the near term, we have to sort of figure out, given that I only have resources for a couple of hundred mental health outreach people, given that I only have resources to fix, 500 homes a week for lead poisoning, that I can only sort of put extra attention on 100 police officers every month. How do I allocate that? How do I figure out what's the right set of people to focus on? And that sort of brings you to the third point, which is, well, the way you decide what to focus on is really a matter or function of what you care about, right? What is your goal? Is your goal efficiency, which basically means try to help as many people as possible with the resources you have? Is your goal effectiveness, which is to eliminate lead poisoning or reduce lead poisoning? Or is your goal equity or fairness, which might mean I may not want to help as many people as possible. I want to make sure that people in different types of neighborhoods or different backgrounds get equally helped, so that one type of one racial group or one geography neighborhood doesn't get left behind. And again, those are not questions that AI can answer, but those are questions that we need to be answered before we can build these types of systems. And those are kind of social, ethical questions that have always been around in any decision-making process. But the problem now is we have to quantify it, and now we have to put in a specific value for how much do I care about efficiency versus equity. And so the question that we're dealing with here in the type of work that I do is really, how do we develop these systems? How do we develop these systems that are kind of collaborating with human experts and human decision makers in order to help them, right? They're not making decisions for them. They're not decisions that are autonomous, but they're helping them make these decisions and helping them make decisions that lead to fair and equitable outcomes. And the most sort of common question that comes up is really, if you look at all the problems that I talked about, one way to structure them as a goal would be to say, as I was mentioning, that I want to help. I have limited resources. I want to help as many people as possible. And that's an efficiency framing, right? Because it could be that if you want to help as many people as possible, your system is going to focus on people who are easiest to help, who are cheapest to help. And what that's going to do is deprioritize people who are harder or more expensive to help. And if that happens, then that's what leads to inequities, right? So this whole group that needs help, but they are much more expensive because they don't live in the middle of cities, and it's more expensive to provide them a service. And that happened, in a lot of places in the U.S., for example, with recently, even with COVID testing, right, where there were tests in different places, but people who were farther away from tests, didn't have public transportation, had a lower chance of getting tested. Same thing is going to happen with vaccinations, right? And same thing happens with other services where you have a lot of services that require, accessibility type things. So there's this question, sort of efficiency is one, right? And often, we, again, thinking about politics, a lot of politicians will use the phrase equity, but now the question we're being asked is, how do you define it analytically so that the systems that we're building can actually help us get there, right? So let's kind of think about what that really means, right? So the first question really comes up. If you look at from the AI and machine learning point of view, there's a lot of work in the last few years on fairness in machine learning, right? And one of the challenges in that area is that the work in that area has really been focusing on a lot of it, if not all of it, but how to make a machine learning model fair. And at some level, it doesn't really matter if the machine learning model is fair or not. The question is, we want the outcomes for the people being affected being fair. And so I'll sort of go a little bit deeper into that in a minute. But so the first question really here is, like, how do we even define what fairness or equity means, right? Because that's not a machine learning question. It's a social, ethical question, but we have to figure out what that means before we can even start measuring it. But once we define it, we should be able to say, can we measure the current state? Can we measure what's happening? Can we understand why things are unfair? Can we improve what's happening? But then our systems that we're going to build will never be totally fair. So then we have to figure out, how do we mitigate the impact of unfair systems? How do we design our interventions, how we design our actions so that they don't result in unfair outcomes? And then how do we monitor and evaluate these things, right? And the reason for these types, the structure sort of is, you could sort of, have to figure out, like, where does this come from? Like, why are we seeing these types of outcomes? And the biggest reason really is because the world is biased. And it's not because our machine learning models are biased, not because our data is biased. It's because the world is biased. And because the world is biased, it generates artifacts that result in a lot of these issues. But many cases, the data that we collect, the data we use in our analysis, is also biased. And I'm sure you've talked about that. If you're talking about politics surveys, or everybody using social media and assuming that it's the ground truth and all those type of things, we know a lot of these things. But there are some sort of more subtle biases as well, right? For example, this, I call it the label bias, right? It's the example I was giving around police officers. The way an incident is judged to be unjustified versus justified is based on an internal affairs review. So the internal affairs process looks at a case of use of force and says, oh, it's justified. And I'm using that data to train my machine learning system. And if that internal affairs process is totally corrupt, then I'm going to build a system that's totally corrupt and totally useless. It's never going to say something is justified. And I can't just correct that by looking at it, because I need to go back and ask the internal affairs team, hey, now that you're not corrupt anymore, this decision from 3 years ago, would you reverse this decision? So that becomes really tricky on historical data, where a decision that was made, or, again, when we see somebody is going back to jail as an outcome, well, it's not, it was in the policies, in the context of that time, this person went to jail. It doesn't mean this person deserved to go to jail. It's just the system was set up that way, that they went to jail. So how do you actually design AI systems that are able to deal with it? That's a really, really difficult problem, right? So the sources are often, world data, and then a source often is how we build the system, and that's completely, our problem as people who build these systems. We introduce a lot of biases based on the design choices we make, in terms of what data we use and what components we use in our pipeline. But then even if all of these things are perfect, right, the way actions are taken using these systems can introduce a lot of bias, right? So I'll give you an example of the lead poisoning example, right, where let's assume for a second that we have a perfect system that is not biased. It's generating predictions for high-risk children in a perfectly fair way. But then the way the system is being used is, the first step is the health department calls people to make appointments for lead inspection. So they call every home and say, we'd like to make an inspection. If those phone calls are now happening in English, a perfectly fair system is going to have perfectly unfair outcomes, because those phone calls are in English. And so people who don't speak English will never be able to make appointments easily. And that's going to leave them behind and have a higher rate of lead poisoning for them, without, the first part being perfectly fine, right? So that's kind of the piece of, if they kind of think about the overall outcomes, rather than saying my model is fair, my data is fine, I don't have to worry about anything else. But we have to kind of look at the entire workflow and figure out how to deal with it, right? Even if we sort of look at when we do our analysis, right, what we in machine learning, we have this entire pipeline that we have, and a bias can come in a lot of places, even in something like this, right? So for example, when we link data together, record linkage, we sometimes miss people. We sometimes, link people together that makes errors, right? Either there are people linked together that are not the same, or people that are the same missed. Now, if you look at, there are patterns in there, like people with long names, with lots of consonants together tend to get misspelled. And that means they often get, missed. And that's not random. And so these mislinking means that we missed a few events about this person. So when we're now making inferences about this person in the future, we're going to be, systematically wrong about them. And some people tend to get more linked. So even for things like when we fill in missing data, a common thing we do is we just say, height is missing. So we'll just do mean height. And if we've got, let's say we've got majority of our data happens to be male and we have a female who's missing height, we'll just impute based on mean. And now we have a female in the data looking much more like a male than they should, right? So there are a lot of these little things that we do that we don't think about, but have downstream implications on bias and fairness. And so another question, right? One of the things, again, if you look at some of the literature for the last few years in this area, what we find is that there's a lot of work on sort of definitions. What do we mean by fairness? What do we mean by bias? And what's come up is a lot of different metrics. Basically, think of it as, there are two types of metrics, right? One type of metric is based on how we distribute resources. So we want to make sure we give equal resources to male and female, equal resources to every country, or equal resources to every racial group, or proportional to some population. The other type of metric has been more based on kind of mistakes. So if we miss people, we want to make sure we miss people equally across different groups. Or if we have false positives, we should have equal rate of false positives for basically every metric you can generate using a confusion matrix. That can become a bias measure. The question becomes, how do we pick which one we care about? How do we pick which one we optimize for or design for in our system? And from a policy perspective, people who are sort of on the policy side looking at these things, they're kind of reaching two conclusions looking at this. One was, oh, there's so many of them, I don't know what to do. Maybe I should just not worry about it. It's too complicated. Or the second conclusion was, there's been some, several analyses that have shown that, well, you can't get all of them. So the conclusion they're reaching is, well, if I use machine learning, I can't be fair because I can't get all of them, which means I shouldn't use machine learning. And neither of them are the right conclusion. Partially it's because we don't care about all of them equally, right? So here's kind of an example. I'm going to zoom into part of it. We developed fairness tree as a way of helping end users, sort of policymakers, think through what is your policy goal and what metrics should you care about. So I'm going to zoom into a specific piece of it, right? And so this is, if the interventions are punitive, if taking an intervention could hurt people, that's things like in criminal justice, bail decisions, keeping people in jail, then a false positive is much worse than a false negative. So you don't want disproportionate false positives, right? So you want you want to make sure that your false positive rates are similar. So that's kind of this side. If your interventions are helping people, so providing them with, the lead inspections or mental health services, then you want to sort of look at the false negative is much worse, because if you miss people disproportionately, it's going to hurt them more than if you intervene incorrectly, right? So that's kind of one way of thinking about it. There's more details here, but at a high level, right, depending on what you want to do with the system, not the prediction, but the action, you care about different types of bias metrics. And so that what we did was kind of develop this type of tree to help them think through what metrics they care about, and then we built, we sort of developed a simple tool to audit their models and their predictions to tell them whether they're meeting those or not. So there's this bias audit tool that we put in kind of the predictions and the outcomes, and then it sort of generates a report that's saying, you're biased, you're not biased, here are the dimensions you're biased in, here's the metrics, and here's what you might do. So that's kind of an example of how we make them go through. And one of the things that sort of comes out with this is, when we actually look at actual building these systems, we find that, before we were kind of looking at it in this way, right? We have some metric, whether it's precision or AUC or F1 or some, pretty much efficiency-focused metric, getting as many predictions right as possible metric. And we would have picked sort of, this yellow metric. What we find is, if we look at this other dimension, we might pick this one there's a trade-off here. And we might pick this green one because I can get a bigger reduction, right? And in practice, it turns out this actually works in a lot of ways. And so actually don't have time to go through some of these examples. So I'm going to skip through an example that is, I'll skip through a criminal justice example that I've been working on. And this is kind of similar to the Kansas example I talked about, is there are, this is work with Los Angeles, where people sort of have these needs around different types of social services, and because they don't get met, they often end up getting arrested and going into jail. So what they wanted to do was to, again, allocate limited resources to people to reduce their return to jail. So we sort of, what we did was we built the first system to predict, again, who's going to come back to jail, to connect with these services. And the first version of it was focused on basically the standard metrics, right? Which is, again, precision, and that had 73% of all the people we predicted were going to come back to jail. 73% of them were going to come back to jail. And that was the most efficient system because it had the most predictions correct and it would allocate resources in an efficient way. Now, when we analyzed that system, we found that it had a higher performance for white people than Hispanic people. And in this system, Hispanics had a higher recidivism rate than white, right? So this was Hispanic recidivism rate, this was white recidivism rate. But when you build a system that's more accurate for white than Hispanic, both rates come down over time. So the dynamics that happen is they both come down because you're helping both, but you're helping a larger percentage of the white group. And so their rate comes down faster. Right? So what this is resulting in is increasing the disparities between the recidivism rates between white and Hispanic. And so then we said, okay, here's option number 2, which is let's build a system that's equally correct. So optimize for the values of equality. That had an additional cost, so it was less efficient, 2%. And here's what it results in. Right? It starts with the same point, but it now helps both groups equally. So you get equal reduction in recidivism. Now, that doesn't increase disparities, but it also doesn't decrease disparities. It sort of just preserves the existing disparities. So let me give them option number 3, which is defining the value. Here's what we care about. We want equity in recidivism rates. And that was another sort of slightly more expensive, but here's the outcome with that. We start with the same point, but now we help the group that has a higher rate more in order to sort of reduce this gap and get to equal recidivism rate. And so from a policy side, again, giving these menus of if you care about efficiency, here's what happens. The disparities increase and here's the cost. If you care about equality, here's what you can do and here's the cost. And if you actually care about equity, here's what you can build and here's what the cost is. And they ended up, deciding to go with number 3, but providing, instead of talking about machine learning metrics and models, all of that stuff is in the background. There was a lot of math and the paper that you can read and write-ups. But for the policy decision makers, giving them this menu of these options, telling them the cost and telling them the potential outcomes was sort of the way to help them figure out how to move forward and how to make these types of decisions. So that's one example. There are several more I'm not going to talk about here, but this type of work is sort of, we're doing a lot of this type of work. We're thinking through what is the overall policy goal, thinking about these trade-offs, and then building these systems, kind of communicating with the people who are making the policy to help them understand how to do this in different resource allocation cases, whether it's sort of COVID or vaccinations or other social services. And, overall, kind of wrap up, right? Like in all of these examples, what we're used to seeing is machine learning and AI, giving us ways to be more personalized, right? It was personalized advertising, personalized political targeting, but also personalized policies. And in general, the goal has been to be sort of how to be more efficient, maybe more effective. But I think now we have to kind of think about it's not enough to be efficient and effective. We need to be more equitable. But our off-the-shelf machine learning systems are not designed to do that. They're designed to be as correct as possible, right? Most of our metrics. And so we have to be deliberate about not using the standard off-the-shelf metrics and seeing, how do I make fairness and equity a primary goal, primary metric in my ML process from the beginning, not just in the model, but kind of overall. And I think that's important for us, is not just to make focus on just the models, because the model can be totally unfair, but you can mitigate that risk and the model could be totally fair. And the results could be horrible based on how it gets used. And I think the last piece I would sort of end with is, these types of systems where kind of fairness and equity centered, we can't really build them as AI people, right? It has to be collaborative across different sectors, and we have to kind of collaborate with not just policymakers, but more importantly, with the communities that are being affected by them, right? Because they need to have a key role in helping us build these systems, helping us understand what the values of this system should be. What does it mean to be equitable? What does it mean to be fair? What are the implications of that? Because the risk is that, this is how a lot of businesses have kind of used machine learning and AI, right? Like, oh, it's just more efficient. It's so much more faster than a human could do. But if we just replicated the human biases and the human decisions that we've made in the past just more efficiently, that's risky. So we have to kind of figure out, how do we not replicate what people have done so far? How do we hopefully improve over that by combining the two things? So that's what I had. I want to leave with just a plug for anybody who's interested in getting involved in these types of projects. We recently launched a few months ago this volunteer platform that connects governments, nonprofits that are looking for this type of help for projects, with volunteers who are interested, kind of data science volunteers, but also managing these projects and doing QA type things where junior volunteers don't work. So if you're interested, take a look, and happy to take questions now, but also feel free to email me if you have more questions. My email is easy enough to find. And then the code for all of these things and content stuff is both on my webpage, but also the code is at this GitHub that we maintain. So thank you very much. I'm happy to take questions. I know I went a little bit longer.
Sure. Thank you very much, Rayid, for the presentation. You have covered a lot of ground, so of course questions are still coming, and I encourage our participants to continue doing so. My first question would be related to your work next to policymakers, to decision makers. So you pointed out how different kinds of solutions, optimizations based on different kinds of preferred solutions before policymakers, right? If there's one thing that you would like policymakers to improve in terms of data literacy, only one thing that you think that would be crucial for improving how AI and machine learning are today used in government, what would that be?
Yeah, I think the one thing that is sort of big thing that's missing is, honestly, that training, right? Because policymakers today, they're getting there, but they're not trained in thinking about any of these things. So where the training comes from is from reading popular press articles. They'll read something and say, oh, this is what AI is. This is what it does. And vice versa, people like us are not trained in what the policy problems are. So when we talk to policymakers, we sort of say things that may not apply to them, right? So like, oh, you can't achieve all types of fairness. So the translation for them is, oh, you can't use machine learning to do anything that's equitable. So I think a lot of it is really getting this cross training for them, so that that's designed for kind of policy context and needs, which today doesn't, and it exists in pockets, but I think they just don't know enough. So I think my first thing would be, don't get training from popular media, because they're not going to the subtleties and the nuances. They're going for generalizations. They're not wrong, but they're not explaining the way that you need to know to make your decisions.
Thank you. So then we have one question from Victor. I guess that there is no silver bullet, but what metrics would you recommend to evaluate equality or equity in a predictive model?
Yeah, so I guess that's the challenge, is that the predictive model is not doing anything. It's not affecting any human being. The model is on your computer. It has some metrics. You have some graphs. It's what you're going to use it for that decides the metrics, right? So again, if I was going to use a predictive model to figure out which students are not going to finish school, and then decide and allocate, let's say I have resources to help 5% of the students in my school, then the one thing I might want to make sure is that certain types of students are not missed disproportionately. So that's false negative rate, right? So I might want to make sure that male and female false negative rate is comparable. And but the attributes that you might care about differ from culture and society in different contexts, right? So it could be racial groups, it could be urban versus rural, it could be students who have certain types of needs are not missed. So it's really kind of, if you, the tree that I was showing, kind of going through that tree and saying, okay, what do I really care about? Which groups, which types of people? And then, but if you want to use that model to then decide something horrible about people, which you shouldn't do in the first place, but the metrics change. So I think that's what we have to kind of think about, is we have to go from models to actions and systems. And those metrics are, any of those metrics can be calculated for any model, but the one we care about more has to be based on what we're using it for, which is the most important thing.
Thank you. So I have a question from Milos. How much can these approaches for optimizing equity or equality can be generalized for different problems and models from your experience?
Yeah, I mean, we've been using it across the board in across areas. So I think they tend to we're finding two types of things. One is we've been testing them in different contexts, in health and education and criminal justice and in policing. But we're finding sort of one of the surprising findings we've had is that, typically you sort of hear about there's a trade-off between accuracy and fairness. And that's sort of, people say that, but empirically we find that in a lot of these problems across different areas where you have limited resources, that actually trade-off doesn't exist empirically. So we're finding is because you have limited resources, you can actually get both, because you have this many people you should be helping, but you can only have this many people to help. And the way you select this group, there are many, many, many ways of selecting this group. And if you're deliberate about fairness and equity, you can select this group in a way that is much more equitable without losing accuracy. So we have a paper right now that we took a bunch of these projects that we'd worked on and applied our bias correction reduction algorithms to it, and found that we could reduce the bias and get to equal disparity without losing anything in accuracy. And I think that's an interesting and surprising result for us. And so now the question is, how do you get that? How do you sort of generalize that and make sure that there are ways of, in different contexts, to do that? But we're finding, but the same thing can apply to, if you're doing hiring systems that are helping recruiters shortlist candidates, you should, the same type of things apply there, where you don't want to miss people who are qualified, and so you want to make sure that you can design these systems, and at least it looks like that they do generalize across different contexts.
All right. So also you showed us a lot of examples from government. May I ask you, what is your take on these kinds of questions that might be asked from the private sector? So, for instance, I have in mind the discussions that are going with regards to the regulation and non-regulation or self-regulation of online media platforms. A lot of the questions and issues that you are raising seem also relevant. What is your take on this problem?
Yeah, no, that's a really good question. And the reason I focus on government is, unfortunately, especially in the US, right, the private sector is not regulated very much, right? So government's job is to be equitable. They can't leave people behind. But unfortunately, we don't ask the same of private sector. They can just fire any customer who is not profitable for them. They don't have to serve anyone. And so in this case, we can't ideally, I think there should be regulation around, sorry. Come on. No. Ideally, there should be regulation around these types of systems, right? Where, sorry, I should have muted all of me. Too many windows. Okay. So I think that the question is, one, whether it's self-regulation or whether it's external regulations, I think the question really comes down to what are the business goals that you have, right? In my case, the policy goals that I'm starting with saying, I have limited resources, but I want to make sure that I'm fair and equitable. And that leads to designing these systems that lead to equity. If you're a business, the question really becomes how much of, what's the cost, what's the price you're willing to pay for equity? And that might be regulation cost. It's just the cost of doing business. Or it might actually be, I think, in a lot of cases, these metrics that we're talking about are really performance metrics. That if you're doing badly for a group that you're supposed to serve, if you fix that, you do better. Now, the question is, how much is it worth for you? If doing the right thing, costs you extra money, but it also gives you extra benefit, then it may be worth as a business decision, right? So I think that's the kind of the challenge with businesses is, if you're hiring, if you're a job board and you're recommending candidates to recruiters, if you miss a lot of people who were otherwise qualified, you're doing a bad job. And so but you're also biased. So if you fix that bias, you might actually improve your performance. So it may not be a cost, it may be an overall benefit. But I think in a lot of cases, these types of things, businesses are kind of focused on the more efficient and effective dimensions because there's no business value for them. And I think regulation is one way of forcing them to say, we need to do this.
Yeah. Let me ask you a last question, this time from the audience. Philip asks, how can we ensure that the population's attitude to algorithms retains a healthy skepticism, particularly given the hype surrounding it?
Yeah, no, that's a really, really, really good question, right? It's again, we as sort of, at least people on the tech side are not very good at sort of explaining what these things do. We overpromise. Again, these things, there's very little about the algorithm. It's mostly about thinking about what the outcomes are, what the goals are, and how to include the people who are being affected in this process. The algorithms are important to get done in the background, but I think we sort of have to make sure that we're being realistic, right? So if we sort of keep saying these things are horrible and they will destroy the world, then we're basically saying that the human decisions that we are making today are so good that changing them would just be horrible, right? Like we know that the human decisions are pretty bad. People are sexist, people are racist. And so we know that that's not the world we want. We also don't want, complete autonomy in these computers making decisions. And so the right thing is kind of somewhere in the middle, but that means that having a society that understands these types of things and can have a conversation around the values we want and around the ethics of these things, and then and then building these systems in a much more transparent way. So I don't think it's an easy process. But I think a lot of the questions that we're asking now they're not new questions. They've sort of existed around policies for a long time, except the scale is very different. And I think that's something important is, if we build one system that's going to make every hiring recommendation decision in the world, before with humans, there was high variance. Like the people were biased, but they were also differently biased. And now if we converge to these three systems that run the world, that's a little bit risky. So I think that's where we have to think about, how do we make sure that there is some transparency around these things, but also there is a lot of kind of local community involvement when these systems are built by the people who are going to be affected by it.
All right. Rayid, thank you very much for your insights, for your experience, for the overall image that you gave us from the work in different fields. That was extremely, extremely helpful.
Thank you. Thank you. It's good to be here.
Thank you very much. So we are arriving at the end of our program. It has been a very intensive day on AI and democracy. So I would like to thank, in the name of of the co-organizers of this track, Stephen and Victor, the participants first for being there, but also the team of AMLD, in particular Sylvain and Pauline. So thank you for your support, and also thank you for being with us. And I hope that you continue being with us during the apéro, the virtual apéro, unfortunately virtual. And we can continue the debates that we had today. Thank you, and stay tuned for other tracks on AMLD. Thanks.